The question is, how do you know that 2 times 5 equals 5 times 2? So let's test it. 2 times 5 means that I have 2 groups of 5. So I will use 2 glasses, and in each glass I will put 5 grapes. And I have a total of 10 because I have 2 groups of 5, which is 5 plus 5. The question is, how do I know that this is the same as 5 times 2? So let's test it. 5 times 2 means that I have 5 groups of 2. So this time I'm switching things around. I have 5 glasses, and in each glass I'm going to put 2 grapes. So 5 times 2 is 5 groups of 2. 2, 4, 6, 8, 10, 10. So 5 times 2 is the same as 2 times 5. So our grape experiment was made possible because of the commutative property of multiplication. And this tells us that the order of the factors can be changed, but the product stays the same. And we proved this with our grape experiment. But does it work with other numbers? Let's try 8 times 9, which obviously is the same as 8 times 9. We could easily switch the factors on the right side of the equal sign, and we can again prove that 8 times 9 is exactly the same as 9 times 8. So we've already learned that because of the commutative property of multiplication, 2 times 4 is equivalent or the same as 4 times 2. But what happens when you have more than 2 factors? Well, I'm glad you asked. In this case, I'm going to make it read 3 times 2 times 4 is equivalent or equal to 4 times 2 times 3. And when you come into a situation like this, you want to use the associative property of multiplication, which basically says that you could change the grouping of the factors and the product stays the same. We're talking grouping because we don't just have 2 factors. We have more than 2, in this case 3. So we're going to want to group them. You always want to group any 2 of them first. So on the left of the equal sign, I'm going to first group the 3 and the 2. And of course, if I group them together and multiply and find the product of 3 and 2, that of course equals 6. And then 6 times 4, of course, would equal 24. So I have 24 on the left side of the equal sign. On the right side of the equal sign, I could group any 2 of those that I want to first. So in this case, I think I'm going to do the 4 and the 2, and I'm going to find the product of those 2 factors. And of course, the product of 4 and 2 is 8. And then when I multiply the 8 by the 3, I have, of course, 24 again. So you could see that I grouped the factors in different ways on both sides of the equal sign. But no matter what I did, I wound up with the same product, which was 24. And this is using the associative property of multiplication, the grouping property. In multiplication, many people think of the multiplication sign as standing for the phrase groups of. So when I do the identity property of multiplication, that means that I am going to multiply any given factor by 1. Now if you think about this, if I were to put in 6, this stands for one group of 6. One group, 6 in there. And naturally, the product would be 6. If I did one group of 9, well, clearly that one group would have 9 in them. Okay. If I did one group of 79, clearly the product would be 79 because I have one group and this is what's in it. Okay. And this is called the identity property of multiplication. And the identity property says that when you multiply any number by 1, the product is always that number. You could see that if I made this 179, clearly the product would be 179 because it's that one group with that much in it. And you could see that connection across the equal sign. This is the identity property of multiplication. We learned previously that often the multiplication symbol stands for the phrase groups of. And we learned with the identity property of multiplication that if we have one group of a given number, the answer will be that number. But what happens when we multiply something by 0? Okay. Well, that essentially means that we have no groups of a given number. So if we had no groups of 8, clearly we would have nothing because we have no groups. Okay. If we had no groups of 81, well, clearly we would still have 0 because we have no groups. No matter what we put here, those no groups will tell us that we are going to have nothing. Okay. This is called the 0 property of multiplication. And the 0 property of multiplication says that when you multiply any number by 0, the product is 0. I like to look at the two factors, and if either one of them is 0, I automatically know what my product will be. Now it's time to practice. Please make sure you have your math journal open to the next clean page and you have your pencil ready to go. I'll also be using a highlighter with my work as it helps from time to time. As a review, we have already learned about the two easier properties of multiplication as being the identity property of multiplication and the 0 property of multiplication. Your job is going to be to write these at the top of your page. We're going to go through a few practice examples and you are going to identify which property is being used and fill in the missing number. Okay. So number 1, if we have 25 and we're multiplying it by another factor and it gives us the product of 25, what is the missing number? You may pause the video while you're working. Obviously, the missing number would be 1 because any number times 1 is going to give you a product that's equal to that number. This is an example of the identity property of multiplication. Let's try a second one. Let's suppose that we had 1,250 and we multiplied it by another factor and our product was 0. What is the missing number and what property of multiplication am I using? You may pause the video while you work. Clearly, we remember that any time you multiply one number by 0, we will get a product of 0. So the missing factor in this case would be 0. because this is like saying 1,250 groups, and each group has nothing in it, so clearly we would have nothing. Number 3. 1 times some number will give you a product of 1,500. What is the missing factor? And what is the name of the property that we just used? You may pause the video while you work. Clearly, we remember that this is a great example of the identity property of multiplication, because we've identified one of our factors as being 1. So 1 times a number will give you a product of that number. So clearly the missing number would be 1,500, because this is like saying I have one group and there's 1,500 in that group. So my total would be 1,500, or 1,500. My 4th example. 15 times 1 equals what? You may pause the video while you work. Clearly, this is another example of the identity property of multiplication, because we have 15 groups of 1, or one group of 15. And either way you look at it, it's going to give you a product of 15. On the next page of your math journal, we're going to focus on the other 2 properties of multiplication. And they were the commutative and the associative. And the commutative tends to be 2 numbers being multiplied by each other. So an example would be 2 times 4 would be equivalent to 4 times 2. The associative tends to be when you have more than 2 factors. So, for example, 2 times 3 times 4, and if I mix those around, I could say, well, that's equal to 3 times 2 times 4. So we're going to do some practice problems that will be using these 2 properties of multiplication. Number 1 is going to be 2 times 3 is equal to something times 2. Please find the property of multiplication used and the missing number. You may pause the video while you work. Clearly, this is a great example of the commutative property of multiplication. And one way I like to look at it is the equal sign is kind of like your dividing line, your midpoint. Do I have a 2 on this side? Yes. Find a match on the other side? Yes, there's my 2. I have a 3 on the left side. Do I have a 3 on the right side? No, I don't. So clearly that would be the missing number, because 2 times 3 is 6, and 3 times 2 is 6. A great example of the commutative property of multiplication. Number 2. We're going to do 2 times 4 times 5 equals 4 times 2 times missing number. You may pause the video while you work. You could also think of this like a teeter-totter. And on both sides of the teeter-totter, you want the same amount. So if you think of the equal sign as your dividing line, you could do a matching activity. You could say, okay, I have a 2 over here on the left. Where's the match for the 2? The match is right here. I have a 4 over here on the left. Where's my match on the other side? There's the 4. Over here I have the 5. Where's my match for the 5? Uh-oh, I don't see it. So clearly 5 would be the missing number. And this is an example of the associative property of multiplication. Now we're going to dig a little deeper into the associative property of multiplication. So for number 3, I'm going to write identical things on either side of the equal sign. So in this case, we will do 2 times 4 times 3 equals 2 times 4 times 3. But after we write this, we're going to put the parentheses, the sets of parentheses, in different places. So over here on the left, I'm going to put the 4 times 3 into my set of parentheses. But over here, on the right, I'm going to do the 4 and the 2. And that's going to tell us what we need to do first. So on the left, we do what's in the parentheses first. And over on the right, we do what's in the parentheses first. So once I've looked at that, I say, what's the product of 4 and 3? Well, of course, it's 12. And I'm left with the 2 times 12. And of course, we all know that that is 24. Over on the right, I'm going to do the parentheses first. And in this case, it's 2 times 4, which is 8. And I'm left with 8 times 3, which of course is 24. So I've proved that the associative property works. And the associative property is where you could change the grouping of the factors. Remember, the associative property is all about grouping. And I could change the grouping, and my product will stay the same. Now I want you to try one just like number 3. Number 4, we're going to do 2 times 5 times 4 equals. And then I'm going to use these same factors, but I'm going to mix them around. So I'm going to put the 5 first, and then the 2. And of course, I want to make sure I have the same ones. So we've got 5, 2, 4 would be the missing one, times 4. And I'm going to put parentheses here around the 2 times 5, and here around the 2 times 4. And I want you to try to solve this one on your own. Look back at number 3 if you get stuck. Please pause the video while you work. Okay, this is what we should have. Because we have parentheses on either side of the equal sign, we always want to do those first. So over on the left, the product of 2 and 5 is 10. And we're left with 10 times 4, which of course equals 40. Over on the right, we want to do the parentheses first. And 2 times 4 is 8. And we are left with 5 times 8. And we all know the product of 5 and 8 is 40. So because here at the bottom we have 40 equaling 40, we know that with the associative property of multiplication, we were able to group differently. But we wind up with the same factor, or the same product at the end. Now for number 5, we're going to get a little creative. We're going to say that Kyle has 3 boxes, and each box has 5 shirts. And we're going to say that Mr. Shaler has 5 boxes, And each box has 3 shirts. And what I want to know is, who has more shirts? So pause the video and see if you can illustrate this and find the answer. Okay, we're back. Now, you don't have to get really fancy on these drawings. For Kyle, I'm going to represent the boxes just by some basic squares. And it says that he has 3 boxes, and each box has 5 shirts. And then it said Mr. Shaler, he has 5 boxes. So I'm going to just draw 5 squares. And each of his 5 boxes have 3 shirts. So who has more? Well, the answer is they have the same amount. Because Kyle has 3 groups of 5. Mr. Shaler has 5 groups of 3. And because of the commutative property of multiplication, which says that you can rearrange the factors and the product will still be the same because of the commutative property, I could say that we have the same number of shirts. For number 6, we're going to try a word problem. I'd like you to copy this down, please. If you multiply a number by 1, can the product ever be greater than that number? Take a moment, pause the video, try to answer this question, and then unpause the video to see the answer. Okay, we're back. Now, dissecting this word problem is kind of easy. We're talking about multiplying a number by 1. We've already talked about one of our properties of multiplication, the identity property, is saying that any number multiplied by 1 is going to be that number. For example, 12 times 1 equals 12. 100 times 1 equals 100. Okay. So this is saying if you multiply a number by 1, can the product, which is the answer when you multiply, be greater than that number? Okay. And the answer is no. Because, try it. Okay. We've got any number multiplying by 1. Okay. It could be 10 times 1 will equal 10. No more, no less. It could be 1 times that number, and it could be 17. One group of 17 would be 17. No more, no less. So the answer to this problem is clearly no. If you multiply a number by 1, can the product ever be greater than that number? No. It's going to be that number. No more, no less. Our next practice round does not require you to write or copy anything down. I have 5 equations. Each one is going to be an example of either the zero property, the identity property, the commutative property, or the associative property. Just to review, the zero property says anything times 0 is 0. The identity property, which if you look at the I, it kind of looks like a number 1, says that anything multiplied by 1 is that number, like 10 times 1 equals 10. The commutative property is usually going to have 2 factors. And then the associative property, we are talking about grouping. So the associative property, usually you're going to look for parentheses or more than two factors. So for each one, you're going to have 5 seconds to identify it as either the zero, identity, commutative, or associative. So number 1, 5 times 3 equals 3 times 5. That is the commutative property of multiplication. Remember, we have 2 factors on each side. There's no need to group. Number 2, 2 times 3 times 4 equals 3 times 4 times 2. That's the associative property. Even though we don't have parentheses, it is still showing more than 2 factors being multiplied. So when I do start multiplying, I will need to add in my parentheses. For example, here I might multiply the 2 and the 3 first, and on the right I might multiply the 4 times 2 first. Still the associative property of multiplication. Number 3, 1,200 times nothing equals nothing. Clearly, that is an example of the zero property of multiplication. Because we are winding up with a product of 0, we have no groups of 1,200, or we have 1,200 groups of nothing, still equals nothing. Zero property. Look for that 0. Number 4, 1,200 times 1 equals 1,200. That is the identity property of multiplication. And as I said earlier, that 1 almost reminds me of an I. The identity property says that you multiply anything by 1 and you get the same answer. I like to think of it like this. Okay? Because I'm multiplying it by 1, you're going to have a match with the first factor, that's not a 1, and the product. And number 5. We have in parentheses 2 times 10 times 6 equals 10 times 2 times 6. And that is an example of the associative property. And on either side, this time I have my parentheses, which tells me to do that first. And if I solve for each side, I've got 20 times 6 equals 10 times 12. And when I do further multiplication, I find that on either side, I have a product of 120, the associative property.